Hello everyone, my name is Ahmed and today's tutorial is going to be about Exploratory Factor Analysis, EFA. We will refer to EFA, to Exploratory Factor Analysis, as EFA throughout this tutorial. EFA is used by researchers when developing new skills. It may also be used to confirm skills used in past studies. In this case, in today's tutorial, we are going to use EFA to confirm pre-existing skills. I have two examples of EFA today. The first example will confirm the items that load under different factors in a survey instrument. The second example will confirm the items that load under different dimensions of a construct. Without further ado, let's begin. First, you go to Analyze, Dimension Reduction, Factor. Then we transfer all the variables needed for the EFA minus the demographics into the variables column. We define the descriptives, reproduce, click anti-image, click KMO, press continue, extraction. Principal components is the default mode, the default setting. We want maximum likelihood, we click on it, continue, rotation, Pro Max, continue, options, replace with mean, suppress small coefficients. We key in 0.3, that is the value we need. We do not need any value less than 0.3. Continue. It is time to run EFA. We click on OK. We await the results in the output section of SPSS. In the output section, we are concerned with the KMO and Bartlett's test. The KMO should be above 0.7. Here it is 0.9. The BTS, that's the Bartlett's test of sphericity, should be significant. It is significant. Next of concern to us are the communalities, the values. Under the extraction section, we want them to be above 0.3. So any value below 0.3 should be deleted. They're all loading fine. The total variance explained. Here we are concerned with values above above 1. That is, the initial eigenvalue should be above 0.1. And the cumulative should be above 60%. They're all loaded up finely here. Next of concern to us are the reproduced matrix. The residuals should be below 5.0%. Here they are at 4.0%. Next is the pattern matrix. This is where we check for the loadings. As you can see, we have poor loadings on info acquisition, in particular info acquisition 5, and with decision quality 13, the value is 0.4, which is low, and we have a problem with decision quality 8. Then this is what they call Hedgewood. The solution to these low loadings are to remove them in the EFA. So we repeat the EFA while removing decision quality 13 decision quality 11, and info acquisition 5. So 1 gone, decision quality 11, and decision quality 13. 11 and 13. Okay. Let's begin with 11 first. Then decision quality 13. Then we run EFA again by pressing OK. Let's check the KMO is still at a good threshold. Communalities are above 0.3. Yes. The cumulative are above 60%. Residuals are below 5. It is even getting better. Before it was 4.0, now it is 3.0. Now the pattern metrics. Yes. They're all load up above 0.5, which is what we require, and there are no cross loadings. The EFA is complete. We now check for conversion validity. Conversion validity has to do with regards to the loadings, to the items loading to each of the factors they're expected to load. As you can see, all the items under anxiety load up finely, confused load up finely, playful load up, good, conversion validity ticked. Next is the discriminant validity. The way to check discriminant validity is to check if there are any cross loadings. I'm happy there are no cross loadings. The other measure of discriminant validity is to check the factor correlation matrix. What we want are the values on the off diagonal should be less than 0.7. Let's see. You can see the off diagonals. The values are below 7. The only close one is 0.6, which is still below 7. So we are okay. Discriminant validity is checked. Once this the EFA is done, the conversion validity is fine, and the discriminant validity is okay. We report. How do we report? We open the Microsoft Word, open. We copy the party matrix by clicking right, copy. Back to Word, we paste. I beg your pardon, we need to check for the reliability. The way to do that is to go to reliability analysis. The first column here is useful. So we head to the useful construct. We transfer all the items to the items column. Press OK. The Chromebox alpha determines the reliability. The threshold for Chromebox alpha should be above 0.7. As you can see, the Chromebox alpha for the useful construct is 0.9, which is good. So reporting for Chromebox alpha, we could copy the Chromebox alpha here and paste in Word. But the problem arises when we have to copy and paste for each of the constructs, it's going to be it's going to be messy. The Microsoft Word won't be tidy. So there's a tidy way of doing this. We come back to the pattern metrics that we copied and pasted in Microsoft Word. We type in Chromebox alpha. Then for each of the construct, you see each of the column represents each of the construct, each of the factors. So we type in 0.1. We recall our Chromebox alpha is 0.942, 0.942, point. Since we're here, let's enter 0 point for each of the factors. It will save us time. It's a little trick I learned. The next column is for the anxiety variable. Reliability analysis. We'll move the useful construct to the back, and then we transfer the anxiety variables. Press OK. This is the Chromebox alpha for anxiety, 0.934. Back to our Word document, 0.934. We enter it. Oh, sorry. Here, 934. We go to the next column, playful. We transfer the anxiety back and pick the playful items. Transfer, press OK. Chromebox alpha 0.914. Head back to Word document. 914, type in, key in 914. The next column is the decision quality. Reliability analysis. We pick up the decision quality. Do not forget to exclude the poor loading items. That is 11 and 13 if I'm right. Let me cross check. Decision quality 11 and 13, right? 11 and 13, back. Okay. So here's the Chromebox alpha for decision quality, 0.908. We head back to our Word document, 0.908. 908. The next column is for compuse. Compuse. Okay. Chromebox alpha is 0.819, still above 0.7, which is good. We head back to our Word document. That is 0.819. 819. The last factor is the info acquisition. Sorry. We return the compuse, pick info acquisition. Remember, we removed info acquisition 5. So all we need are 1 to 4. Okay. The Chromebox alpha is above zero point 0.7 at 0.841. So we head back to our Word document, 0.841841. So that's it for the EFA. Remember at the beginning of the tutorial, I mentioned I will show you how to, I'll show you two examples. So this is the first example. The second example is to confirm how items that load on the different dimensions of a construct. So we close the first data. Okay. So we begin by analyze, dimension reduction. We define the descriptives again. Continue. Extraction. Next. Maximum likelihood. Continue. Rotation. Promax. Continue. Options. Replace with mean. Suppress small coefficients. Key in point 3. Continue. Then we transfer the items. Press OK to run the EFA. We begin by checking the KMO and Butler's value. The KMO is above 0.9, which is good. BTS is significant. Communalities under instructions are all above 0.3. The eigenvalue are above 0.1. They represent each dimension in cultural intelligence. That is, according to the theory, there are 4 dimensions in cultural intelligence. There are metacognitive CQ, cognitive CQ, metacognitive CQ, motivational CQ, and behavioral CQ. That is 4. So 4 dimensions, and the cumulative is above 60%, which is good. The reproduced matrix is below 5.0%. The pattern matrix, the first dimension loads up well. Second dimension, third dimension. Whoa, the fourth dimension is has a problem. So let's begin with the 2 items that have the same values. Let's remove 1, factor analysis. That is 0. Let's remove the last one, 0.5. Let's run EFA again. Still there. It's gone, but there's another problem, cross loadings. So we go back to factor analysis. We return CO5. We remove CO6, the one causing the cross loading problem. Okay. Pattern matrix. Sorry. CO6. Okay, that was our mistake. We did not remove CO6. Problem corrected. Okay. Yes. Our pattern matrix is now good. All the dimensions, all the items load on the their respective dimensions. The values are higher than 0.5 and there are no cross loadings. Discriminant of validity, let's check. In the